Good evening everyone. Today I will be discussing about Lamport's logical clock. In distributed system, it is not possible to synchronize time across entities within a system. For this very reason, Lamport's logical clock is used. I will be executing Lamport's logical clock in C, for which reason I will be dealing with this problem. So this problem, it shows three processes P1, P2 and P3, in which P1 has 4 events, P2 has 4 events and P3 has 5 events. I introduce a timestamp value 5. So when I introduce a timestamp value of 5, each event in the process is separated by a timestamp value of 5. So the first event in process 1 finishes at 5th second, and the second event finishes at 5 plus 5, that is 10 seconds, and the third event finishes at 10 plus the timestamp, which is 5, which is 15 seconds, and the next one at 20th second. Similarly for P2 and P3. These arrows, they represent casually related event. So process 2, event 2 of process 2 is casually related to event 2 of process 2. So this means that if I call this A and if I call this B, when A is related to B, I check if the value of B, the timestamp value of B is greater than or equal to the timestamp value of value of A. So in this case they are equal, for which reason I'll have to increase the time value of event 2 of process 2. That I will increase by adding the timestamp value to its existing clock value, that is 10 plus 5 equals 15. Similarly here B is casually related to A, and since event 2 or event 3 of process 2 gets over at 15 second, and the same thing happens with event 3 of process 1, which gets over at 15 second, I have to increase its timestamp value. Here when I increase timestamp value to 15, consecutively the clock values of the consecutive events changes. So here the clock value of event 3 becomes 20, and this again gets increased by 5, that will be 25. So the new clock value of event 3 of process 2 is 20, and this this event is casually related to event 3 of process 1. So event 3 gets over at the 20th second, but event 3 of process 1 gets over at the 15th second, for which reason the clock value of event 3 of process 1 must be increased. That is done by increasing 20 plus the timestamp value, which is 5. So the new updated timestamp clock value of event 3 of process 1 will become 25, and its successive event also gets incremented by a timestamp value of 5. So that will be 25 plus 5, that is 30. And now event 4 of process 1 is casually related to event 5 of process 3. This process gets over at the 30th second, but this process gets over at the 25th second. So it is supposed to wait until event 4 of process 1 gets executed to get its message and perform its own operation. For that, this value must be increased by 5. This is the basic logic of Lamport's logical clock. Now let's see how this is implemented in C. Here, the first line, I initialize all my variables. I declare the delay time. I declare the number of processes here. Here here I mention the number of events for each process, this one, and here I give the automated delay values, that is 5, 10, 15, that is these values I give through this statement. And now we have here I declare my casually related events. For this is where I declare my casually related events, and the way I have declared my casually related events goes like this. So C11 is not casually related, so this will be 0, whereas C12 is casually related to C22. Therefore I give this a particular number and I increment this number by 1. So this will be 1 and this will be 2. So since A is related to B, B value is equal to A plus 1. Similarly, B is related to A here, so A value is equal to B plus 1. Similarly here, A is related to B, so A equals some number and B is equal to A plus 1, provided that A and B is not equal to 0 when I am talking about casually related events. So that's how I give my the input from the keyboard. And here I declare a variable called temp. Temp is A. Temp is the A value and new temp is the B value. So this means when A is casually related to B, I implement the logic that I mentioned before. So this is the logic that I implement. These two are the logic. Is the logic. Similarly, I do the same when B is casually related to A. This block gets executed. This block gets executed, and in the end I print my values. So let's see how this works for real. The delay time that I'll be entering is 5, and then the number of processes is 3. Number of events in P1 would be 4, and number of events in P2 will be 4, and P3 will be 5. C11 is 0, C12 will be 1, C13 will be 6, and C14 will be 9. C21 is 0, C22 is 2, C23 is 5, 0. So that is my output. Event 1, so I will refer this with my picture here. Event 1 of 1 is 5, and then we have 10, and then we have 25, and we have 30. So we see 5, 10, 25 and 30. And then we'll check for event 2-1, 2-2, 2-3 and 2-4. It's 5, 10, 15, 5, 10, 5, 15, 20 and 25. That is 5, 15, 20 and 25. Then we have 5, 10, 15, 20 and 35, which is 5, 10, 50, 20 and 35. That's all for Lamport's logical clock. Thank you.